Let us understand, let us consider two events. Then we will understand uh, the addition theorem of probability. So let A and B be two events then addition theorem on probability is probability is means probability of happening of at least one of the event, one of the event A and B is defined as P A union B is equal to PA, means probability of A, plus probability of B minus probability of A intersection B. This is addition theorem of probability. Means if any one of them event has happened out of both, then we can define probability of that by using this. Got it? Now let us know about multiplication theorem. multiplication theorem of probability is if A and B are dependent event and B are dependent events, then the probability of both events occurring simultaneously is given by P A intersection B is equal to PB into P means conditional probability of A when B is already happened. And if A and B are two independent events, then means to happen both events simultaneously. We can find probability of that by using we have probability of B and also conditional probability of A when B is already happened. When they are dependent, okay, because we have conditional probability, obviously this means we have dependent events. Now let us do for independent events. If A and B are independent events, then probability of both event occurring simultaneously is probability of both events occurring simultaneously is given by P means probability of A intersection B is equal to probability of A into probability of B. So let us do in brief both formula again. See, when we talk about addition theorem, it means out of both events, at least one is happening. Okay, at least one is happened. So we need to find probability of that condition. But in multiplication, both events occurring simultaneously. So this condition for dependent events and this is for independent. Got it? So independent, when we have dependent events, then obviously we use a conditional probability. When we have independent event, then we take product of probability of A and probability of B to find probabilities of occurring both events. Okay. So now let us do Bayes theorem. I think we have done that day for conditional probability. Okay, I'm telling you in brief again. Yeah, we have done Bayes theorem, right? So next topic, let us see what we have. Okay, whatever question you have, like application-based question, then you can show me. So shall we start next unit, fourth unit? Hmm? Because this unit ends with Bayes theorem and its application. So application-based question, whatever you have, then you can share me. We will do it during the class. So let's start fourth unit. And first, we have random variable, discrete, and continuous. Okay. I think we have done random variable before also in third unit. So you need explanation or shall we start from the next? In fourth unit, first topic is random variables. But in third, we have done already this. Okay. So let us learn how to find PMF and PDF. Probability mass function and probability density function and CDF. So let us do this. Just few seconds. Just few seconds. probability mass function. In short, we say PMF. Probability mass function can be defined as probability that a discrete random variable, like as we have done in previous unit, like if we have when taking a random example, just for understanding, okay? If two coins together at once, then outcomes we have tail tail, hat tail hat, and hat. Okay. So if we need to find probability for no hat or one hat or maximum two hats. So probability for a particular value of x is said to be probability mass function. Okay. So I'm writing here. So probability mass function. So we will find probability mass function for various distribution like binomial distribution. And let me check which distribution you have. 1 second. Uh, okay, and two-dimensional. Okay. So we need to do for both discrete and continuous. So in discrete, we have generally they give binomial distribution and Poisson. So let us do for both. So probability mass function provides, or we can say probability can be defined as probability that a discrete random variable will be, as we have discussed, I'm writing same here, okay? Will be exactly equal to some particular value. Equal to some particular value. As we have discussed, like if we need to find, and previous we know how to form probability distribution, like we can form as for no hat, x is equal to 0, for one hat, and we have maximum two hats. So probability of no hat, we have 1/4. And for one head, we have 1 by 2. And for two heads, we have also 1 by 4. So we can find PMF for any value of random variable. Like PMF means having that probability that a discrete random variable will exactly equal to some particular value. Like if we are finding for no heads, its probability is this. Are you getting me? So in simple words, Px is probability mass function for a particular value of x. Now, let us do probability mass function of binomial distribution, and then we will do for Poisson distribution. Or binomial distribution PMF. In short, we can take PMF of binomial distribution is given by Px is equal to small x. Small x means value of this x, means value of random variable, is equal to NCx into small p to the power x and 1 minus p to the power n minus x. So let us learn what are these terms, or like these values n, x and small p, where n is equal to number of trials. Number of trials means if we toss a coin 100 times, 1,000 times, like this, then we say them number of trials. And x, value of random variable. And usually we take a value of x is equal to 0, 1, 2, and up to small p. Probability of success in one trial. Meaning is that, like, if we need to find, if a coin tossed 1,000 times and you need to find probability to get 700 hats. Okay, 700 times or 700 hats out of 1,000 trials. So in that case, probability of success means to get had. So probability to get success in one trial is 1 by 2. Remember, when we toss a coin one time, then probability to get hat or either to get tail is 1 by 2 for both. Remember? Yes. So small p is probability of success in one trial. And 1 minus p, we can find just subtracting 1, like 3 from 1. Okay. So this is PMF of binomial distribution. You got each and every step? All right. Okay. So now let us do PMF for Poisson distribution. PM probability mass function. Probability mass function for Poisson distribution. Actually, there was a lot of background noise, so just remove that. So let us continue. Okay, let's once rejoin the class, okay? Because this class is going to be over. So let us rejoin once.